today we're going to take a look at parallel and perpendicular lines. Okay, so if we look at the slopes, of parallel and perpendicular lines, we can say that two lines are parallel, meaning they will never touch if they have the exact same slope. Okay, two lines are parallel if and only if they have the exact same slopes. Two lines are perpendicular, meaning they meet at exactly a right angle, if and only if their slopes are opposite, reciprocals. What does that mean? Flipped around how? Like, so if I give you 4/3, what would the opposite reciprocal of 4/3 be, JT? So the reciprocal would be 3/4. Okay, reciprocal just means flip the fraction. Okay, so what does the opposite part mean? Right, take the opposite sign. Okay? So opposite part, oops, that's part. Opposite means change the sign. So if it was positive, make it negative. If it was negative, make it positive. So for 4/3, the opposite reciprocal would be negative 3/4. Okay? Take the opposite sign and flip the fraction. What about negative 2/5? What's the opposite reciprocal of negative 2/5? Positive 5/2. What about the opposite reciprocal of 1/2? Negative 2/1. What about the opposite reciprocal of negative 4? Positive 1/4, right? Because even if I don't see a denominator, the denominator here is 1. So the opposite reciprocal would be positive 1/4. Okay? So let's take a look at calculating some slopes of lines and determining whether they are parallel or perpendicular, or neither. Okay? It's possible that neither of these things would happen. Right? So if two lines are parallel, the slopes will be exactly the same. If two lines are perpendicular, they will have opposite reciprocal slopes. So in this example here, I want to find the slope of the line between A and B, and then find the slope of the line between C and D, and compare those two slopes. Okay, so if you remember our slope formula, which you do need to know, y2 minus y1 over x2 minus x1. So if I want to find the slope of AB, I first need to label those points, x1, y1, x2, y2. Okay, so if I label my points A and B, I'm going to have x1, y1, x2, y2. So plug those values in here. So y2 minus y1, I'll have 5 minus negative 1. So remember, whenever we're plugging in a negative, use parentheses so that we keep those negatives and subtraction signs straight. Then in the denominator, x2 minus x1, I will have 1 minus negative 1. So 5 minus negative 1 would be the same as 5 plus 1, which would be 6, less, and then 1 minus negative 1 would be 1 plus 1, so 2. Then we always want to reduce as far as possible. So 3 over 1. Okay. So you guys go ahead and find the slope of CD. Okay, and then we'll compare them. Get out some notebook paper or another note sheet. Yep, that looks good. So did we get 1/2 for the slope of CD?
Yeah.
Yeah, I think we ended up getting 2 over 4, but that reduces to 1/2. So now let's compare the slope of AB and the slope of CD. Okay, we got 3 over 1 for AB, and then 1 over 2 for CD. Those are obviously not the same, right? Are they opposite reciprocals? No, right? So these two lines are not parallel because the slopes aren't the same, and they're not perpendicular because the slopes they are not perpendicular because they are not opposite reciprocals. Okay, so down here, okay, they graphed those two lines for us, and we can see on the graph that they're not parallel, right? They do touch, they do cross each other, so they're not parallel, and they're not perpendicular either. Okay, they do intersect, but that intersection is not at a right angle. Okay, so down here, okay, we want to practice a few of these. So I don't know, let's do one more together, okay, and then I'll have you guys practice a couple. So we're just determining whether these two lines are parallel, perpendicular, or neither. So we need to calculate the slope between MN and then the slope between R and S. So for my slope of MN, I'm going to label x1, y1, x2, y2. Plugging that into y2 minus y1 over x2 minus x1. So I will have 4 minus 3 in my numerator over 2 minus 0. So I get 1 over 2 for my slope of MN. Now the same thing for RS. So I will have, let's label x1, y1, x2, y2. So my y2 minus y1 will be 4 minus 1 over 8 minus 2. So yeah, so we'll end up with 3 over 6. Does that reduce? It does. Yeah, this will reduce to 1/2. So I got 1/2 for the slope of MN, 1/2 for the slope of RS. What's the relationship between these two lines? Parallel. If the slopes are the same, these two lines are parallel. Okay. So let's take a few minutes here. Okay, you guys try a couple of these. Okay, so calculate the slopes and then compare them. Okay, if they're the same, the lines are parallel. If they are exact opposite reciprocals, they're perpendicular. And if neither of those things apply, then they're neither, not parallel nor perpendicular.
Every time I look at
They're opposites, but they're not reciprocal. So we have to have both of those things to be perpendicular.
You got one that's like twice as thick. It's so good. It smells so good. And it just, guess what it is? It makes you happy. Not tired. It makes you laugh. Yeah. Like you're not sad about nothing. You're not sad about nothing. You're like, even if you're
Next week.
my cat died sweet. You don't always think everything.
No,
you're happy.
when
You're
you-
happy. My dad was happy too.
freaking laying down all night long and stare at the ceiling, rethinking every life choice you've ever made. Exactly, because you can't sleep.
It's not great. Like I was on some stupid shit. There's my dad. He was gone. Yeah, they're not waiting about that for a half hour.
Dude, his laugh so funny.
It's so soft too. What he's got right now is so soft.
What's that? Oh, my cheating.
You lose.
Alright, I think these should be our answers for 2, 3, and 4 up here.
Excuse me. Or S. I got negative
We got reduced.
You got more?
She got
So I think number 2 ends up being perpendicular. I think we get slopes of 2 over 1 and negative 1 over 2. Number 3, we get slopes of 1/5 and negative 1/5. But that means they are neither parallel nor perpendicular. Okay, one's positive and one's negative, so they're not exactly the same. And then they're not reciprocals of each other. Okay, for them to be perpendicular, I would have had to have 1/5 and negative 5 over 1. Okay, so this one is neither. And then for number 4, I think we get slopes of 2 for both of these. Okay, so those would be parallel. Any questions on determining whether lines are parallel or perpendicular? Good. Okay. Did I hit record again? I can't remember. Yeah, I did. Okay. I don't remember doing that. So, real quick, okay, this last part, we want to start thinking about lines that are parallel and perpendicular. So I'm going to go back to, where is it? Is it this one? Yeah. So on these, okay, it says graph a line with these characteristics. So first it just says graph a line with a slope of 4 that goes through the point 6, 2. Okay, so first, let's just find 6, 2, so 3, 4, 5, 6, 2. So here's the point 6, 2. And I want to graph the line that has the slope of 4 that goes through that point. How would I do that? How would I find a line that has a slope of 4 that goes through that point? Yeah, so from this point, I'm just going to go up 4, right, 1, okay? 4 is the same as 4 over 1, right? So this line, okay, is just going to end up looking like this. Now, for the next two, okay, it says graph a line that's parallel or perpendicular to something. So in number 6, it tells me I want to go through the point 8, 5. So 8, 5, 2, 4, 5, 8, 5 is over here. But now I want this line to be perpendicular to this line. Okay? If two lines are perpendicular, what's the relationship between their slopes? Opposite reciprocals. So I want to have the opposite reciprocal slope of this line. Well, what's the slope of this line? Which, if we think about y equals mx plus b, the slope is 2, right? So the slope of this line is 2. But if I want a perpendicular line, I need the opposite reciprocal of 2. So what's the opposite reciprocal of 2? Negative 1 over 2. Okay, negative 1/2. Because if my old slope, if the slope of this line is 2 over 1, and I want the opposite reciprocal of this slope, my new slope will be negative 1 over 2. So what this is saying is graph the line that goes through this point with a slope of negative 1 over 2. So here's my point, okay? I'm going to go down 1, right 2, okay? Or I could go up 1, left 2. No, it's not perpendicular to this line. Okay, this line that we graphed was a separate problem. Okay, we didn't graph the 2x plus 4 line. So yeah, that's a good observation, right? The two lines that we're graphing are not perpendicular. Okay, but this would be the graph of a line that is perpendicular to this line that goes through the point 8, 5. So the key here, whenever we see perpendicular, we need to think opposite reciprocal slope to this one. Okay? Now, the last one says goes through the point negative 2, 5, and then is parallel to a line that goes through these 2 points. Okay? So parallel, what's the relationship between slopes that are parallel? They're the same, right? So what I want to do here is find the slope between these 2 points, and then use that exact same slope for this line. Okay? So I'm going to do this real quick since we're about out of time. So my slope would be 7 minus 2. My slope's going to be 3 over 5. Okay? So I'm going to draw a line that goes through the point negative 2, 5, 5, with a slope of 3/5. This coordinate plane isn't real good. So up.
No, all the posters do today.
Over
No,
5.
I said
Okay, this line will end
It's
up
due by the end
being
of class. You get the class.
over here somewhere.
Who you